Now let us see how we can find out any general term in the binomial expansion without writing all the terms from the beginning, right? So for that, let us try to find out a pattern, and from that we will derive and remember the direct formula to find out any general term. Let us start by writing the familiar expansion of a plus b raised to n. We know that is the first term is nc0 a raised to n. Okay, I will purposefully write b raised to 0 so that we see the pattern. Then the next term is nc1 a raised to n minus 1 b raised to 1 plus nc2 a raised to n minus 2 into b square, and so on. And lastly we have ncn a raised to 0 and b raised to n. Right. Now if we try to look at the individual terms now and give them the term numbers. So here we have the first term t1, okay, as shown here. Then we have the second term t2, t3, and so on up to the last term is tn plus 1, because if you remember in the expansion of a plus b raised to n there will be n plus 1 terms. Now let's try to correlate the individual figures. That is, when we had the suffix as 1, that is when we wanted to find the first term, we observe that the lower number in the coefficient, that is NCR, the R is 0, and similarly the power of B is also 0. So that is, it is 1 less than the term number. Then we also observe that it is the 0 which is subtracted from n, which gives us n, which is nothing but n minus 0. That is the way to visualize that. Let us confirm whether this theory works for the other terms also. When we have to find the second term, you see it is 1 less as nc1 and the same one appears as a power of b. So that is confirmed, and the same one is subtracted from n, which becomes a power of a. So here our formula is, it seems that it is matching and it's working. Let's confirm for one more term. In case of t3, 1 less, which is 2, 1 less, which is 2, and 2 is subtracted from n, which becomes the power of a. So now here it's clear that we have got the required result. Now for that, let us imagine what will happen in case of tr. Okay. We will need 1 less, so that means r minus 1. Then the same r minus 1 would be the power of b, and the power of a will be n minus r minus 1, so which is ultimately n minus r plus 1 as the exponent of a. Let us also try to imagine how to find the term t r plus 1. Okay, now whenever we have r plus 1 here, of course the coefficient will be NCR because r is 1 less than r plus 1. Then b will also have the coefficient as the exponent as r, and a will have the exponent as n minus r, isn't it? So this is the rth term, this is the r plus 1th term, and so on. Now if you see, out of these two results which we have got in terms of some general number r, okay, which result is more convenient for remembering? So clearly it is the result of tr plus 1. So therefore we remember this result as the formula for a general term in the binomial expansion. Remember that the formula for tr is not wrong, it is perfectly fine, but it is slightly clumsy. So better we remember the formula for tr plus 1 as the general result. Alright. So therefore we will now write the formula for the general term of expansion of a plus b raised to n. So therefore for a plus b whole raised to n, suppose we want to find the term tr plus 1, that is given by ncr a raised to n minus r and b raised to r. So this is the formula for any general term in the binomial expansion. So if we know what is a, what is b, what is n, and if we find out what is r, clearly we can directly write down that particular term without the need of writing all the terms from the beginning. Right? So as an example, suppose we want to find out T7 in some expansion, then 7 has to be same as r plus 1. So that means in the formula we'll have to put r as 6. If you want to find T12, then we'll have to put r as 11 and so on. Let us practice this with the help of one example. Find 8th term in the expansion of 2x minus 1 upon root x whole raised to 12. Right. Now here in this case 2x is our a, so therefore a is 2x, it corresponds to 2x. Then b is minus 1 upon root x, note that the second term is negative. Then the power of the binomial expansion is 12, which is n, so n corresponds to 12. And we have to find the 8th term. So in case of 8th term, we have to take r as 1 less than 8, that is 7. That's it. Now let us write the formula for a general term which we have just seen, that we write in terms of tr plus 1 given by ncr a raised to n minus r into b raised to r. That's it. So now we write it for the given example. So therefore in our case T8 will be given by n is 12, so we have 12c, r is 7, then a stands for 2x raised to n minus r, that is 12 minus 7, into b, which is minus 1 upon root x raised to r, that is 7. That's it. We have to merely simplify this. So this is equal to 12c5, then you have 2x whole raised to 5. Now you see minus 1 raised to 7 will be nothing but minus 1 only, and here we have root x standing for x raised to half, and that will get raised to power 7. We write 12c5 as it is, that you can solve separately, it's not the important point in this question. So 2 raised to 5 is 32 into x raised to 5 into minus 1 upon x raised to 7 by 2. Let's take that minus term now outside, that is minus 12c5 into 32 x raised to 5 minus 7 by 2. So that gives us, I will write 32 first, 32 into 12c5 x raised to 3 by 2. So that's the 8th term in the expansion of the given binomial expansion. So you see the power of the formula for the general term. We did not need to write all the first 7 terms to catch hold of 8th term. We could directly jump to that term with the help of this particular formula.